these algorithms, behind this capability, is to separate the computations and the data that's done and analyzed in your system, on your chip, in your memory, from the much, much larger data set that's held on disk. And so the idea here is to use data chunking techniques to go and access small blocks of data. Pull them in. Leverage in this picture, take your core number 0 to do I/O off of disk. And then pipeline this into the rest of your computational power within your chip, within your single machine, within your server, to allow them to perform the computations while your first core keeps pulling data in and out. Well, then what you can do is you can extend this same concept to grid computing, to parallel computing on clusters, for example. Use the same algorithms, the same math, but now distribute them across a much larger way. Okay? And so this is the fundamental technology that we're using to speed up and address the big data analytics challenge. Okay? And then the idea is, once you've done that, once you've figured out how to distribute these computations, now you can have a single analytics platform that you can apply across a variety of big data architectures. And one of the things that we're seeing start to shape up is that it's still very cloudy, and there's a lot of confusion, and there's a lot of disagreement amongst people in the IT field about how should I architect my big data to later analyze. And there's one camp of people that's been sort of classically trained that says, look, what I do is I have my data in a data warehouse. I'm going to extract it. I'm going to create a local file. I'm going to do interactive analysis on that file. It's a pretty classic way of working. But it's still very, very important today. But the difference is today you need to be able to do it on very large data sets. The other direction, though, is there's a lot. Let me ask this one. How many people have heard of Hadoop? Quite a few. So Hadoop is a distributed computing architecture built on a technology called MapReduce. And MapReduce and Hadoop has become a very hot field and a very popular potential solution for architecting big data. However, there's a different camp that says, well, gee, maybe Hadoop isn't the solution for everything. Maybe I don't want to duplicate my data by extracting it every time. Instead of bringing my data to the analytics, I'd like to bring my analytics to the data. And so there's a camp of people, especially from the large companies, that are promoting the use of in-database analytics, i.e. to execute the analysis that you're doing inside the database appliance itself. But again, the important thing here is each one of those has some pros and cons. Some are good for interactive analysis. Some are good for more batch jobs due to some of the latency. Some are good for very high-performance jobs, okay, but more expensive. The key is to be able to leverage a single set of algorithms, a consistent set of statistics across any one of these without having to rewrite, duplicate, or change your models. It's very important from a data governance and from a control standpoint to not have different analyses on the same set of data. So what does this all turn into? This all turns into, I mentioned earlier, this thing of setting up an analytics center of excellence. And this is what it starts to look like. So I talked earlier about these data scientists and them being brought in to develop these models, to be a bridge between IT and the business, to be a statistician and be a programmer. What's happening is that these companies, these large companies, are setting up this analytics center of excellence centered around a data scientist, where they can then, just like we showed on the last page, develop their models, host them in a central cloud or grid environment, and then be able to farm those models out to things like a Hadoop cluster, where the data lies there. Farm it out to things like a database appliance, where the data lies there. Or farm it out to something like a high workload cluster for computationally intensive implementations. And then take all of those, aggregate them back together, and deploy them out to these business users via the cloud. Well, that's a perfect stopping point because that was the last slide of my first, the first part of my. So maybe what I'll do is stop there since we're getting the disruption. Let me stop for some questions. Is there any questions that people have?
I'd like to ask.
Sure.
When you're looking at conventional enterprises,
Yep.
wherein I agree what your point with respect to big data, the doubt and the confusion arises with 1 gigabyte or petabyte, what is big data?
Yep.
Typical enterprises we normally see are airlines, telcos, banks,
Yep.
who have humongous amount of data.
Yep.
So they have built some data warehouse, they have built their own cubes, they are using Teradata, they're using some various in-appliance
Yep.
models and so on and so forth. I'm trying to analyze, I'm trying to differentiate this from organizations like Zynga.
Sure.
So their video logs,
Sure.
That's a different issue.
Sure.
So you're saying when this data scientist as a key part of the problem,
Yep.
anybody who's doing ETL,
Yep.
anybody who knows how to do BI,
Yep.
can't you call him a data scientist?
Okay, so let me repeat the question for everybody else. So the question was, there is sort of two camps of companies, and I'll illustrate some of these for you as well in some of these case studies, and I think it'll bring some of this to life, but let's set this up. So just want to repeat it. One is the traditional company like an airline or a manufacturing company or shipping company or bank that has traditional data warehouse, Teradata plus cubes plus business intelligence, and let's distinguish that from somebody like a Zynga or a Facebook or a startup like that has unstructured web data, et cetera. So absolutely right. And the tool sets that those two will use are different. That's exactly right, because they have different sets of challenges, but they also have legacy issues. I think the important thing here is that the value, to get value out of analytics, you cannot force an organization to throw away the IT investment they've made for the last 10, 20, or 30 years. You need to be able to leverage that. Okay? So then part two of your question was, well, gee, is anybody who's doing ETL out of a traditional data warehouse and putting into BI, are they a data scientist? And to that one, I would argue no. And the reason I would argue no is that to be a data scientist, you really have to bring the statistics in, and you have to bring the mathematical model in. Okay? And so I think that's the distinction. It's somebody, it could have been the person who was managing that ETL and then went and learned how to do the statistics. Okay? So the point is the field of training didn't necessarily have to be the statistics on the first hand. It could have been that ETL, that computer science training on the first hand, and then they learned this one. Or it could be the other way. Okay? But those two need to be there together. When I gave this talk the other day, somebody asked me, well, gee, which one's more important? And I had to think about it for a minute, and I wasn't quite sure. And here's the way I answered. I said, well, gee, if you've got two kids, it's like asking which one do you love more. Okay? And the short way to say it is that if you're a great programmer, if you're great at ETL and you've learned a little bit of statistics, you'd be a pretty good data scientist. If you're a great statistician, a little bit of programming, you can be a pretty good data scientist. If you're a great programmer and you're a great statistician, you can change the world. Other questions?
To conclude on that point,
Sure.
do we need data scientists in just these three industries with the current volumes of data they have? The airline, telco, or banks. Just take these three industries. Do we need data scientists for these industries while running a business?
Let me tell you. Let's go through. Let me share some things. Let me share what people are doing, and let's see what the answer is. I think it's a fair debate. I would argue yes. I would argue that I don't think there is a single industry, and there's not a single industry that we work with as a supplier, and I don't think there's a single industry that I'm aware of that is not using R and doing this data scientist in some way. I think the challenge is to make it pervasive, and I think what we're going to see more and more going forward is a separation between those people, those companies in any industry that choose to do this and gain a competitive advantage versus those that choose not to and fall behind. So I think your question was quite apt. What I wanted to do for this part is just run through and share how are some of the innovative companies using this technology to tackle some of these problems in a variety of kind of big data regimes and give you a feeling for what's being done. So let's start, I think, in financial services, right? You talked about the banks, so let's give a couple of these. I mentioned the flash crasher. People are using R to model, detect, put triggers in place, detect asset chunks. So this is a classic big data problem because you can think about each one of these points. Imagine if you were just taking an average historically, where you're taking slices from here, 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 you would have missed this kind of jump in your historical data. By being able to take and pull in this tick-by-tick level data, you can understand, well, jumps like this are normal sometimes, and they're aberrations. And you can model that in and know when you should pull the trigger and shut the market down, okay, versus when you should allow things to continue trading. But let's take things in a different direction. One of the things that's really fantastic and interesting about R is the ability to leverage modern and alternative data sources. So, for example, Twitter. I'm not very good at Twitter. I don't do these things very well, but obviously has gained a lot of popularity. People have created tools to be able to extract trends, sentiment, etc., directly from Twitter, pull them into R, and use them for analysis. So, for example, there was a hedge fund that was started, I think it was in the Cayman Islands, that actually used Twitter sentiment, Twitter input, as one of the factors in its financial trading model. Okay. So let's go in a different way. Let's use this one. This was kind of a fun case. There was another tool created to pull trends and sentiment out of Google. And so this author and this guy doing the study, he asked, well, gee, let me ask the question, is there a correlation between the Berkshire Hathaway stock price and people who are searching for Anne Hathaway on Google? It sounds like kind of a ridiculous proposition, right? But some people thought there was, right? And they thought when there was a new movie coming out that Berkshire Hathaway stock price went up, and could they capitalize on this and try to make money? Well, you can see this one, if you look at people searching for Anne Hathaway, you look for Berkshire Hathaway, in fact, there's not a correlation, but who knows, it was at least worth looking. Internet and social media. So again, this is back to your other one. Those are sort of the old school industries, but again, showing the way to balance traditional, banking, stock market control with some of the modern techniques and modern hedge funds. Let's go into the modern world a little bit and talk about some of these internet and social media tech companies. So we hinted at Zynga earlier. So they're getting ready to go public in the U.S. This was from their S1 filing, and I mentioned this earlier. They generate 25 terabytes per day of user data that they actually actively use to improve their user experience and improve their profitability. How does this work? Well, if you look at this, this was for a different online gaming company, one that we worked with, to understand, well, gee, how can we improve user retention, profitability, etc. What happens is that we kind of said, well, gee, angry birds of a feather flock together. What does that mean? It means that when people stop playing, when they play an online game, the reason why they leave is they reach something that wasn't very fun, right? It was a bad part of the game. It was, you tried to sell more money. You asked them to log into something else. They get frustrated and then they leave. And what happens is there's clusters of those things together. And so what you can do, you can model this out, and if you can understand, well, gee, what's my probability of a user staying versus leaving as a function to where the page is? And so if you look at this, you can see there's a very small number of pages here at the very end that cause users to want to leave. So what you can do, again, by aggregating all this stuff, by leveraging all this massive set of data, you can understand, well, what are the characteristics of those pages that make people want to leave? Highlight them for your designers. Instead of just saying, hey, you got to go fix my game, you can say these 2 pages are a problem, figure out how to do them, how to improve them, pull them out one by one, and now all of a sudden, instead of having 75% user retention, you can have 95% user retention. Okay? And think what that can do for your customer growth and improvement of profitability for an online gaming company, where churn is one of the most important things that they have to deal with. Facebook. Facebook, as I mentioned, is an extensive art user. They use it in a number of different ways, not just for research and development of their network models, but they also use it internally to study what they call colleague-to-colleague interactions. And so what they've done is they basically mapped their social network of their employees to understand how their employees interact with each other. And they've used this model to do things like rearrange their seating charts and recommend two people to sit next to each other. Or maybe two people that shouldn't sit next to each other because they talk too much. Okay? Things like setting up optimally constructed teams. So I don't know if anybody in here works for a service industry, like a consulting shop or Deloitte or something like that. One of the things that those shops really face challenge with is how to structure and how to staff teams with these diverse people from around the country, or maybe in many cases around the world. Right? You can use it with these kind of social network models. But a little bit of a different perturbation, and one to really think about, is companies are starting to now use this not just for internal analysis and understanding of their employees, but to actually bring in external data sources as well. So think about the trend, especially, I'm a little too old for this, but of students, of kids posting online to various, whether it's MySpace or Facebook or Twitter. And what's happening in the U.S. now is that there's actually startups that are mining this data and creating databases of information that people have put of themselves on the web. And what they're doing, they're providing as a service to do background checks for companies, such that they can now create models to understand what's the correlation between the characteristics of people who applied for my job, who came in and either succeeded or failed within my company. And I did an interview a little while back, and I was talking about the social implications of this. And one of the things that's both interesting and scary to think about is, when I was a student, when I was in college, you were very well trained to write your resume, to structure it well, to put a suit on, and to go to your 30-minute interview and be on your best behavior to try to get this job. But what's happening today is students are writing their resume, they're applying for, and they're interviewing for jobs before they even knew that job exists. Okay? So the whole paradigm of hiring and human resources is changing because of these big data analytics. Another one, you talked about, structuring, well, is there a difference between companies of an airline company versus a Zynga, right? And a traditional data warehouse versus something like a Hadoop infrastructure. Well, here's an example of one where a single company was able to evolve and learn more about its business by bringing in a second one. I talked earlier about having different data architectures and needing to be able to provide common analytics across them. So in the U.S., there's an online travel company called Orbitz. So I don't know if anybody's heard of Orbitz. The local one here, somebody help me with the local online travel company. What was it? Zuji? Okay, exactly. This is the Zuji of the U.S. And so Orbitz, they've actually completed 160 million bookings. And what they did is they stored those bookings in a traditional relational database. I don't know whether it was Teradata or what it was. And then they would analyze those. And they say, how successful were my bookings and those customers I won? But if you've completed 160 million bookings, how many failed bookings were there? How many people searched and explored but never went and actually closed the transaction? Okay, and they actually lost that. And they didn't have that information in the past. So what did they do? They brought Hadoop into the mix to actually say, let me keep my transactional data, my successful bookings, my data warehouse. But now let's bring in the non-transactional data, i.e. searches, and store them in a Hadoop cluster. And now let me do analysis on both of those together and see if I can learn something different. And so they started to implement this, and they learned things like, from a user segmentation standpoint, when somebody comes in and they're using Safari, they actually spend more money than somebody who comes in using Internet Explorer. Okay? So you can think of interesting, why that may be the case, but think about the implications of then what you can do with that data, that information, and to target different campaigns or different opportunities. Maybe you offer the 5-star hotel to the person who comes in on the Safari browser, and you offer the 2-star hotel to the guy who comes in on Internet Explorer. So is there any life sciences people in the room? Not really? Okay, so we'll skip through this pretty quickly, although I will share one with you because, for those budding data scientists, there may be a chance to make some money. So I talked about the genomics. We'll skip over this. It's kind of technical, but it's very heavily, it's a big model. It's a computationally intensive kind of problem. But I think this is one that is of interest and could be fun for you guys. So, as is pretty widely publicized, healthcare, particularly in the U.S., is a big problem. There's obviously been lots of debate and lots of news recently about debt ceilings and crisis and default in the U.S. The number one driver of that is healthcare expenditures growing uncontrollably. And on the plane ride over here, I was actually reading a research article from Harvard, Professor of Harvard, a few years back, and his opening line is, the healthcare industry in the U.S. is possibly the most inefficient IT organization in the world. Okay? And the result of that is, 5 years ago, things like $30 billion spent just in the U.S. alone on unnecessary hospital admissions. And so the challenge is, how can you predict and prevent these unnecessary hospitalizations? Okay. Well, this is pretty interesting. So right now what's going on, there's a partner of ours, a company called Cabot. And they're a small startup out of Australia. And what they do is they host data analysis competitions where they post a data set from a company and then invite people from around the world to solve the problem. And what they do is they offer prizes. Well, traditionally there's been $5,000, $10,000 kind of prize to solve this problem. Well, what they launched about 3 months ago is they launched something called the Heritage Health Prize, where the Heritage Health Network is a California-based hospital network. And they provided a data set. And they said, look, our goal is to try to understand, if we know patient history, medical records, etc., can we build a predictive model to identify who is most at risk for hospitalization before they show any symptoms? The prize that they offered to come up with the best model for this, $3 million. Worthwhile to be a data scientist. I'll wrap up with some of these. Was there some government people in the room? Anybody working? One maybe? Okay, few? Okay, great. So the next couple slides I'll just go through pretty quickly were for a talk that I gave at the CIA a few months back. And so again, you can think about intelligence and research of the government to try to prevent things like terrorist cells and attacks and things like that. So the example here was to illustrate the fact that statistical techniques and statistical techniques that exist within our environment are not limited to a single vertical application. And this is a very important concept to understand. And it's a great limitation of thinking in a black box world. Okay? And if there's one thing that I would encourage you to do is to not think in a black box world, to think in a transparent world and understand that techniques, that tools can be applied across different problems. Okay? And the example here is, we talked about before about social networking analysis, about Facebook using these techniques to model and recommend, well, gee, if you're friends with him and he's friends with him, maybe you should be friends with him. Well, you can do the exact same thing if you're a bank and you want to understand credit card fraud. Right? If this transaction is suspicious related to this transaction, maybe this one is fraud. But you can also do the same thing about predicting terrorist cells. If this guy's a known troublemaker, if he starts talking to him, what is his relationship? Or think about things like the recent revolution in Egypt, right? And that being driven and instigated over things like Twitter. Right? you're a government, you want to understand, well, where is the trouble going to be? Right? To be able to track and look for these upticks in activity between certain groups of people. So the point is that the ability to not rely on a black box allows you to tap the best tools in a variety of fields. Let's skip this. And I guess the last one, that I would end up with is talk a little bit about visualization, about graphics. I gave some examples earlier. We talked about, I showed the Facebook graph. I showed some of the other financial trading graphs. This is some work that we did. Again, it was kind of relevant for the CIA folks. But we went back and we analyzed WikiLeaks. So everybody assumes followed all of the controversy around WikiLeaks. And what we did is we used it to say, look, here's the data's out there. It's public now. Let's tell you something. Let's show what we can learn from looking at this in a graphical fashion. And so R, as we talked about before, has a very, very extensive collection of graphical capabilities. The way that I like to describe it is to say, if you can imagine it, or you can draw it on a whiteboard, you can create that graphic in R. Okay? And so here's an example. We started off and we looked at, well, gee, let's look at some attacks, right? I.e., who's getting attacked? Is it an enemy attack? Is it a friendly attack? Is it a neutral? Or do I not know? And then let's look and see if there's any kind of patterns in the data, over the years. And what you see is well, gee, there's these kind of bumps, up and down. That's kind of interesting. Gee, in the summertime it gets too hot, right? People are too hot to go outside. In the wintertime it cools off a little bit, so they come out for some attacks. It's kind of interesting. It's not really that interesting. But you see them starting to grow over time, becoming particular. If you look at the east area and some other areas, not so much text, but it doesn't quite give you the whole story. Let's take the exact same data. Let's look at it visually in a different way. Well, let's create a map. And now let's look as we grow over time, going from 2004 to 2005, 2006, et cetera, where do these attacks occur? And what you see is you start to see this pattern developing where here we're kind of random, and then you start to get this. And so I put this up on a room of there's 200 people in the CIA, and all of a sudden the light bulbs go off, and they look at it and they say, that was the road that was being built. So now all of a sudden all these attacks are happening around this road, where A, it's easy for people to get around, but it's an easy target because it concentrates all the people in one direction, and people could set up the bombs along the side of the road. So again, an example of signals and patterns that are able to be found. On the last page, it didn't really tell you much. Right? But all of a sudden, you take the same data, you look at it in a different way. All of a sudden, you can learn something, and you can make a decision on it right away. Okay? So the power of visualization to bring to this data analysis to match the models is very important within this big data analysis kind of goal. So that's the end. Right on time. So I hope that was a little bit of an overview of sort of some of the challenges and ways that advanced analytics centered around this technology reuse, what some of the companies are doing. I'd love to open it up, ask some questions, hear some thoughts, hear some comments, hear what you guys are doing, what your challenges are, either in the public forum or hang out and have some tea afterwards. So thank you for your time. Thank you for listening. Is there any questions?
Just a big hand.
No.
One last question. So your description of a data scientist has been so exciting that I'm looking at it again to start off with. But to understand that further, one thing which I didn't see much from now in your presentation is the importance of understanding that particular industry.
Sure.
Because
Sure.
what we offer end of the day is a technology that can churn data.
Sure.
But what is to be taken out? What
Sure.
is the perspective that we should be analyzing?
Sure.
Okay, that is completely a domain expert's capability.
Yep.
So essentially, after a point, do you think that this will get shadowed?
Sure. It's a very interesting, important question. So let me repeat it for everybody else. So the question was, I talked about the importance of a data scientist to understand the data analysis part of it, but the domain expertise is equally important. And will this data scientist get overshadowed by the domain expert? And what are the risks of that? And I think it's a very real possibility. Let me answer in two ways. The first one is that I think that's the challenge, and one of the important skills, and maybe I should change my slide for that, is, it's kind of, if you go back to one of the points that I want to, how do I do this here? Making here is that, anyway, you get the point, is that they need to be a bridge between IT and between the business, and I think that's an important skill of the data scientist, is to be able to at least speak the language of the domain expert. Okay? So again, you don't have to be the expert, but you should be able to speak their language, understand and listen to the questions that they're asking, so you can help interpret the data appropriately. Okay? So that's part number one to your answer your question. But let me answer the second one. Answer in a second way, is that as a company, the biggest industry that we sell into is financial services. And in particular, we sell into the large investment banks. We sell into hedge funds. We sell into the credit card issuers. And one of our largest customers is a very, very prestigious investment bank. And we're selling to their quant shop, quants. And our customer, the person who brought us in, he said, look, one of the most important reasons I'm interested in using this platform, this thing called R, is that I cannot hire enough people with domain expertise in the quantitative finance space. And what I want to be able to do, because they have this common language that they share of this thing called R, now I can hire people from the biostats world, from the social networking world, from the, whatever else you want to say, and they can come in, they can speak this common language. I can teach them finance, and I can teach them to listen to me pretty quickly. So not only do I have a bigger talent pool now, I also get cross-learning with these other industries. And he goes, look, I want every competitive advantage I get. And if I can bring somebody in who knows something using social network analysis that they learned at Facebook, and that can give me a competitive advantage, I want it. Other
would you be able to elaborate a bit more about R and Cloud and Hadoop? I think there were some pictures on that.
Sure.
I'd like to have a bit more details if you could.
Sure, absolutely. I'll answer at a very highest level. We can follow up more offline. But so R and Hadoop are really complementary technologies. And R is Hadoop is a distributed data processing framework based upon a paradigm called MapReduce. Came out of places like Yahoo and Google use it. And then R is a statistical processing, statistical analysis language like I talked about. However, there's a tremendous opportunity to integrate those together. We have done that, and we have just started releasing those connections to the market. The idea behind this, think back to the one on, let's see, where was this? Think back to this page. And the idea here is that our goal as a provider of statistical analysis software, statistical tools, is to keep the statistician thinking and programming in the language that he's used to, in this case R, and to make the underlying data architecture transparent. Okay, so let me give you an example. R has a little bit of a steep learning curve. It's kind of hard to learn. So is MapReduce. Okay? So to find an R programmer today, there's more of them. It's becoming very popular. Same thing with Hadoop. But still, the talent pool isn't all there. To find somebody who knows both R and Hadoop at the same time is kind of 1 in a million. And so what we've done is we've basically enabled that our programmer to tap into things like HDFS, HBase, and write analytics jobs for Hadoop streaming directly from the R environment in the language that he's used to, in the syntax that he's used to, without knowing how to write a MapReduce job. Okay. So that's at the very highest level. What I would say is check out our website. We just started releasing some technical information about that, and we'll actually be hosting a kickoff webinar within the next, I forget the exact date, the next couple of weeks. Our CTO will be giving a webinar about how to integrate and how to leverage R on top of Hadoop infrastructure.
Maybe just let me elaborate. So the other thing that we have done is that for certain very popular and often used elemental algorithm, right, elemental packages, it's been optimized to run on multi-core CPU cluster and now Hadoop, and it's transparent to the end user from the statistician's or data scientist point of view, right? Like what Jeff has mentioned, it's going to be very hard. So if it's 1 in a million, you're going to find maybe 5 or 6 in Singapore that knows Hadoop and R. So the whole idea is to have the same line of code that you have written, right? You put it into your data processing pipeline, and then depending on whether you are running on a Hadoop cluster, on a cloud, on a HPC cluster, or on a big workstation or SMT server, just toggle a what they call a context switch. In layman code is the option, right? An option flag to say, oh, for this code I want it, I want to run it on a cluster, or this code is supposed to run on a Hadoop. So from programmer perspective, it is the same function call, right? Y equals to fx, for example, right? It doesn't change, and it's just the setting that change, and the code will run and handle the underlying structure.
So maybe I could just follow up with that one. So instead of, I just want to get a sense of where the roadmap goes. I guess in some ways you could imagine that you could have R just on the cloud. Forget about Hadoop.
Yep.
So is that one of the options there?
Absolutely. Yes.
And if there is, can we have a bit more clarification on where you are? And
Sure.
Yeah.
So if you look at this slide, right, which is deploy R, it basically hides the
But you're still running on Hadoop on this one.
No. So in deploy R, it makes it, in a sense, it makes it transparent. So the data scientist will basically upload the model, right, into deploy R. And the user, or maybe the organization, right, will have certain characteristics. Okay, for this set of jobs, run it on Hadoop, this set of jobs, run it on a cluster, and so on. But from a data scientist perspective, right, his focus is on writing the algorithm and the models. And which one runs best, probably he needs to work with IT to find out which one runs best. After that, they can set up the workflow. But with that one code, you can basically direct it to run on Hadoop, on a cluster, or on a cloud. So from a cloud perspective, that one is work in progress. There are some ideas on how to scale up to the cloud. But today, you can go and use it on a Hadoop-based cloud or on a MPI-based cloud. So today, it runs on MPI, so you can actually run it on a Windows cluster. End of the year, you can run it on a Linux cluster on the cloud.
Okay, thank you, Lawrence, for the explanation. Let's give Jeff a hand. Then we can ask Jeff more detailed questions over Teams. Thank you very much for attending the webinar.
Thank you.